Alright, good day. Today we're going to talk about section 9.1. We're going to talk about multiplying and dividing rational expressions. And we're going to start with doing a little review on multiplying and dividing with fractions, because fractions are rational expressions. The word rational comes from ratios. So we're going to start discussing those a little bit. You notice we saved adding and subtracting for the next lesson. So those are a little bit harder because of common denominators, but let's take a real quick look at multiplying and dividing fractions. If you had things like 3/4 times 5/8, when you multiply these, don't get confused. Everybody always wants to cross multiply because you're so used to hearing that term, but that's not what you're doing when you're multiplying. You cross multiply when you have proportions or two fractions equal to each other. When you're multiplying, it's really simple. You can multiply straight across. 3 times 5 is 15, and 4 times 8 is 32. 8 times 2 is 16, 32, yes. And that would be your answer. You can also, look at reducing them. If you get fractions that you reduce, for example, if you had 3/5 and 20 over, 12. You can reduce your fractions before you multiply. So, multiply, not equals. So you could look at reducing the 20 over 12. You don't want to change that to a mixed number because that makes things a little bit harder. I think it's easier if you get them to a improper fraction. So you could reduce this to 10 over 6, and that you could reduce to 5 over 3 by taking a 4 out of the top and bottom. Or you can just multiply them straight across and then factor that out when you're done. I think it's going to be easier to write this as 4 times 5, and this is going to be 4 times 3. So the 4's over 4 will cancel out. So 20 becomes 4 over 5, the 12 becomes 4 over 3, and really the 4 divided by 4, they don't cancel out, but 4 over 4 is 1, so those become like multiplying by 1. And now when you multiply, you actually get 3 times 5, you get 15 over 5 times 3, which is 15, and then you can simplify that to 1, because anything divided by itself is 1. So let's talk about doing this with dividing fractions. 2/3 divided by 5/4. Okay, nothing can reduce offhand. A lot of you remember keep, change, flip. Keep, change, flip. And that's exactly what we're going to be doing here. So we're going to keep this fraction the way it is, 2/3, change it to multiplication, and flip this one over. So usually when I see that, I'm going to rewrite them the other way. I'm going to flip this one over automatically and change it to multiplication. So 2 times 4 is 8, 5 times 3 is 15. 8 over 15, they don't have anything in common, so that's reduced. That's exactly what I want. Okay, so now we're going to talk about doing this with rational expressions. So we're going to start throwing in some variables. Okay, I thought that was paused, but obviously it was recording. Sorry about the long time writing that. Let me scroll this example up, and we're going to simplify a rational expression 2x times x minus 5 all over x minus 5 times x squared minus 1. Another way of rewriting this, remember with multiplication there's associative commutative properties. We can switch them around. So this is really x minus 5 times 2x over x minus 5 times x squared minus 1. And I just rewrote them that way because remember this is multiplied, everything's multiplied together, and this fraction, anything divided by itself, cancels out, so you can cancel out your terms just like you did with reducing fractions, and that ends up giving you 2x all over x squared minus 1. Which, that's a nice answer. It's a good starting point, but it's not 100% where we want to get for this final solution. So I'll put this in a box, but there's some other conditions we have to take into account on this rational expression. To finish with this solution, we actually have to go back to our original equation, and we need to look at this in detail. And what we want to do is make sure that we're not dividing by 0. In other words, we cannot have anything here equal to 0, because that would give me 0 in a denominator. You're dividing by that bottom number. So we have to take into consideration these situations. And I notice here that x squared minus 1, well, that will factor out. That's a difference of squares. And that's going to be x plus 1 and x minus 1. If you want to actually factor that trinomial, you can write that out and factor that. X squared plus 0, x minus 1. That's where we did the negative 1 times x squared, negative 1 x squared. What are my factors of that? Plus 1 and minus 1. And you can put those in as your middle terms and factor that out. And that's going to end up giving you these factors. Plus we also have this here, x minus 5. That's my original three values, 3 terms on the bottom of that, and we cannot have any of those equal to 0. So what we cannot have is where x minus 5 equals 0, x plus 1 equals 0, or x minus 1 equals 0. When you're solving these 3 equations, which obviously is going to give me x equals 5, x equals 1, and negative 1, let's track 1 from both sides, and x equals 1 over here. Now, literally, that's how we've solved it with equations, but what you're saying is with these denominators, with these values as your denominator, you cannot have x minus 5 cannot equal 0, this cannot equal 0, and this cannot equal 0. And that will translate simply down here, same symbol, x cannot equal 5, x cannot equal negative 1, and x cannot equal 1. So those are excluded values that go into the solution over here. So this is kind of like the second part of my solution for that problem. Okay, so for this example, we're going to simplify, and there's going to be an extra little step in here because we can cancel out factors top and bottom, but you'll notice on this one we're going to get a slightly different scenario. So I have z squared w minus z squared over the quantity z cubed minus z cubed w. So what I'm going to do is I'm going to start factoring these top to bottom. Remember, you can't just cancel out individual terms, you have to cancel out factors from your numerator and denominator. So I notice on the top these each have a z squared in common. So I'm going to factor that out, and that gives me z squared, and when I divide it, or z squared times what value would give me my first term? It's going to be w minus 1. Remember, you can always look back. You should be able to distribute that and get back to your original part of the problem. And in my bottom, I notice both of those terms have a z cubed in common. So I'm going to factor that out, which is going to give me 1 minus w. Now, as you can guess, the z squareds, up on the top you have z times z, on the bottom you have 3 of them. So the 2 up here will cancel 2 of them down here. So that z cancels z, that z cancels z, and you're going to be left with w minus 1 over z times 1 minus w. Now, my terms are exact opposites on the top and bottom. So what I'm going to do at that point is on this top, or the bottom, it doesn't really matter, but I'm going to factor out of the top, I'm going to factor out a negative 1. So I'm going to rewrite it as negative 1 times, it would be negative w plus 1. And remember, if I distributed this back in, I would get my top value. So that would be negative times negative would give me a positive w. Negative 1 times positive 1 would be negative 1. It would give me that numerator over there. So I now have z times 1 minus w. Although they're written a little bit differently, the terms in my parentheses are exactly the same. I'm just going to switch the order around. 1 over z, and this one is now 1 minus w. I'm just switching them around because the w is negative, the 1 is positive. And on the bottom I have 1 minus w, just to show you real clearly that those are the same. So since you have factors on the top and bottom that are the same, they cancel out, and that will then leave you with 1 over z. So that would be your final answer. You also have to keep in mind that you cannot have z cannot equal 0 or w cannot equal 0. And that's because going back at your original equation, if you got z and 0, you can't have your original factors. Oops, sorry, not 0. We have to go back and look at this. This top thing, the numerator in the very original problem had these two factors, 1 minus w. So these cannot equal 0, because that would give me 0 in my denominator. So if I set those up, z cannot equal 0, or 1 minus w cannot equal 0. Now let's start looking at this. We're going to subtract 1 from both sides, so negative w cannot equal negative 1, or w cannot equal 1. So that's my two excluded values. Let me go back and change this to a 1. So z cannot equal 0 and w cannot equal 1. So that goes along with my answer here. There's my actual answer, and these are my additional conditions on that problem. Okay, so new page of paper, and I've got probably 4 more examples for you. There's going to be a lot of examples this time. We just finished example 2, so we'll call this example 3, and we're actually going to multiply rational expressions this time. The other ones we were just simplifying. Okay, so for this example we're going to do 4a over 5b multiplied by 15b squared over 16a cubed. And one way to think about these, I don't think it's the easiest way, but it kind of helps you see what's going on, is I'm going to write all of these out in their prime factors. So literally if I were to multiply all of these together, it doesn't matter that they're actually two separate fractions, because everything on the top is multiplied and everything on the bottom is multiplied. So I'm going to write it out as 2 times 2 times A times 3 times 5 times B times B. So I'm going to write the prime factorization of my numerator and the prime factorization of my denominator. And on the bottom I get 5 times B. And then for 16 we have 2 times 8. 8 is 2 times 4. And 4 is 2 times 2. A. Now keep in mind, all of these are multiplied together. I could put parentheses in them to make it real clear that I'm multiplying factors. I'm not going to put the dots between them, which just makes it more confusing. But now that I have the prime factors, or the factors of the top and bottom, I'm going to simply cancel them out, because if you wrote these as fractions, 2 divided by 2 gives me 1. And on the top we have a 5 and a 5. Are going to cancel each out. 5 divided by 5 is 1. I have a B, and a B cancels out. I have an A on the top, A on the bottom. They're all canceling out. And I have another 2 on the top, cancels the 2 on the bottom. On the top I have a 3 and a B, and I don't have any more of those on the bottom. Nothing's matching up. So when I get done with this, I'm simply going to put all my terms back together. I have a 3 times B on the top, 3B. And on the bottom I have 2 times A, which is going to be 4A squared. Okay, so now we just simply multiplied and we reduced, and that's my final answer. Keep in mind there would be exclusions on these original values. You couldn't have A or B be a 0, because you'd be dividing by 0 in that case. So let's move on to the next example, make this a little bit harder. Okay, to start with on this problem, we're going to be dividing rational expressions. So I have two fractions divided, and we're going to do the same as we do with regular fractions, that keep, change, flip. Matter of fact, when I see this written on a page, I'm usually going to immediately write it as multiplication and flip over that last fraction. So I'm going to immediately go to this step. 4x squared y over 15a cubed b cubed. I'm going to change this to multiplication, and I'm going to flip this guy over. Keep, change, flip. So I'm going to put 5ab cubed on the top, and on the bottom I'm going to put 2xy squared. Okay, now if I wrote all these out in prime factors, you can do that, and I'm going to also solve this another way. Let me get a little bit more paper here. Scroll up so we just have this example. If you technically look at the top, I have 2 times 2 times x times y times 5 times a times b times b times b. So we have a lot of prime factors up there. On the bottom of this, I've got, let me see if I can draw a line here. And my denominator is going to be, start with 15, we have 3 times 5, A, B, 2x, y. So a lot of stuff, and I'm not going to write those out each time. I'm going to kind of look for a shortcut method. But now we can start canceling factors. I have a 2 on the top, 2 on the bottom. I have a 5 on the top, 5 on the bottom. I have an x on the top, x on the bottom. Cross that out a little bit better. I have a y on the top, y on the bottom. Remember, y and y cancels out. 5 divided by 5 cancels out. That's why I'm doing that. I have an a on the top, a on the bottom, b on the top, b on the bottom, have another b on the top, b on the bottom, have another b on the top, b on the bottom. I'm looking if I have anything else top and bottom that cancels out, and I don't see it. So what I'm left with here is, on the top I have 2x, and on the bottom I have a 3 times a times y. So 3a squared y. And that would be my final answer. Keep in mind we can't have an a or a y or even a b be 0, because that would give me 0 back in my original expression. Not too concerned about that right now, but we'll be looking at that in the next problems as well. So example 5. Actually, before I go on to example 5, let me take another look at this and see if there's a slightly different way to do this problem. What I'm going to do is I'm going to combine all my stuff on the top and bottom, which 5 times 4 gives me 20 x squared times y times a times b, so I'm going to get x squared times y times a times b cubed. And you may remember back when we did polynomials that we simplified these directly by subtracting exponents or canceling things out. 15 times 2 is 30. And then we have, I'm just going to go back to, I put x's and y's first on the top, I'll put them first down here. So we have x, y squared, and then we have a cubed, b cubed. So if you look at this in a condensed version when we multiplied it out, you can see, well, the 20 and 30 are both reduced, or you can factor a 10 out of each of those, and that gave me my 2 out of 3. So these are each divisible by 10, or you could just drop those zeros. X squared over x leaves me with 1x on top. So an x down here will cancel out one of these, leaving me with x. And then you look at your y's. This y value will cancel out one of the y's, because this is y times y on the bottom. So one of them up here cancels out one of them here. And you can see how we still get back to my original problem that I have here. The a's, 1a on top will cancel out 1a on the bottom, and the b's will cancel out all together. So that actually ends up giving me the same solution that we got by writing out all the factors above it. So now let's look at one, make it a little bit harder, or a lot a bit harder, just depends upon your take on it. And that will be example 5. Okay, so for example 5, here's what we got. We have trinomials, we have binomials. This is multiplication, so we don't have to do the keep, change, flip. If this had a division symbol in there, we'd have to flip it over, but since we're multiplying, it's pretty straightforward. But what I'm going to do is I'm going to factor out my trinomials over here and factor out the other values as well, and break these down, because I can cancel factors top to bottom. I cannot just cancel like an x over x, because those are terms of a trinomial, but I can cancel factors. So going back to factoring trinomials, you have to be really good at that. You may need to review that if you don't remember that from before. But that's going to give me factors of x plus 4 and x minus 2, plus 4, x minus 2 for my top term. And the bottom one is going to give me x plus 3 and x plus 1, plus 3, x plus 1. And when I come over here, I can factor a 3 out of both of those terms, x plus 1. And on the bottom over here, I simply have an x minus 2, but keep in mind that is a term, so what I'm going to do is just start reducing and cancel out terms from left and right. Remember, these could all be written together, so the order of them doesn't matter. So the x minus 2 cancel an x minus 2, and x plus 1 on the top will cancel an x plus 1 on the bottom, and I am simply left with 3 times x plus 4 on the top, and on the bottom I have x plus 3. That's what I'm putting for my answer. You may see this multiplied out by the way, I think it would be best to actually distribute this back in. So you'll have 3x plus 12 over x plus 3. So that would be a better answer. I'm not sure how it would be left on multiple choice. I'm sure it would be multiplied back in, but just try and simplify it out and do as much of the math as you can. Alright, let's take a look at our next example, and I'm probably going to wrap up with this one. And the way these are written are just enough to give you a little heart attack, so don't panic when you see this. So, example 6. And I'm going to pause the recording here, so this is also a good time to pause it once the example pops up and you can write the whole thing down. So I'll be back in a second. Alright, you see something like this, don't let it scare you. It's just a more complicated way to write it. We're going to call this a complex fraction. It's a fraction over a fraction. Really, this could be written as a squared over a squared minus 25b squared divided by a over 5b minus a. It's really the same thing, except we wrote it as a fraction over a fraction, which just freaks you out. Keep in mind with division, we're going to keep change flip, so we're going to keep this as a squared over a squared minus 25b squared times, and I'm going to flip this over, 5b minus a over a. And now we want to see if we have any factors that are in common on the top and bottom. And keep in mind, this term here is a difference of squares. So I can actually factor that out as a plus 5b, a minus 5b. And then I notice over here, that parenthesis didn't show up. There it is. Two of them are now. Since these are multiplied, and I notice up on the top I have a 5b minus a, and then on the bottom I have an a minus 5b. So what I'm going to do is I'm going to do that -1 trick and factor a -1 out over here, or multiply by -1, which ends up giving me negative 5b plus a. Keep in mind, if I distributed this in, I would get that term. So it has the same value. Also notice a negative 5b plus a is the same as a minus 5b. So I'm going to cancel this and cancel that, top to bottom. And I have an a squared over here. That's a times a. So an a over here is going to take care of that a on the bottom. And I think that's all I can do. But what do I have left? When I get down here on the top, I have a times -1, or negative a. And on the bottom, the only things I have left is a plus 5b. And that's where I'm going to end up this problem. So there's my final answer. Keep in mind, a or b can't be 0 because that would be giving me division by 0 when bad things happen. So I'll let you go with that. Simplified complex fraction. That's all 6 examples for section 9.1. And your practice problems are on your paper. And I'll also put a couple review problems up on your thing up here to answer. Make sure you're getting them. And if you have questions, email me. Let me know what's going on. Talk to you later.